Okay, today we're going to be reviewing the properties of multiplication. So we're going to take a look at some of these. Let me get back to the beginning here. Okay, properties of multiplication. There are three main ones that we work with in fifth grade. Those are commutative, associative, and distributive. Our first that we're going to talk about today is commutative property. Commutative property, the numbers are the same, but their placement changes. One way to remember that I've told you guys before is my husband commutes, sounds like the word commutative, to work with his secretary. It is always Brian and Diana in the car, but who sits in the driver's seat changes. Same is true for commutative property. It's the same numbers, but their order changes. For example, if we have 4 times 2, that's the same as 2 times 4. 8 times 3 is equal to 3 times 8. 9 times 6 is equal to 6 times 9. Both sides of the equation sign will have the same answer. So let's try some of these. Let's think about what 8 times 9 would look like if we're using the commutative property. I want you to take a second and think about it. Okay, so if you feel like 8 times 9 would look like 9 times 8, you're correct. How about 7 times 1? Taking a second, think about it. You think 7 times 1 would look like 1 times 7, you would be correct. How about 4 times 3 times 8? This one has several options. You could do 3 times 4 times 8, or you could do 8 times 3 times 4, or you could do 3 times 8 times 4. Regardless, your answer would be the same. Okay, associative property of multiplication. The numbers stay in the same order, but their grouping changes with parentheses. Remember how I told you to remember is that if you put the two halves of parentheses together and then add a little tail, it looks like an A. So if I were to put those together and add a little tail, it looks like an A. A for associative. It's one way to remember it. So let's look at some examples of associative property. Okay, for associative property, this would be an example of 5 times 3 times 4. My 5 times 3 is grouped on one side of the equation sign. On the other side of the equation sign, my 3 times 4 is grouped. Why this is even important is sometimes you need to group friendly numbers together, or numbers that are easy for you to multiply. So this is the whole point of associative property. The next example, 7 times 8 times 9, my 8 and 9 are grouped, and then my 7 and my 8 are grouped. And then I have 12 times 3 times 1 times 8. Again, you have different options here, and so we change the grouping from 12 times 3 to 3 times 1. So let's do some examples. Let's do some of our own. So let's think how we could group these numbers. Remember, my numbers stay in the same order, so I'm going to go ahead and write down my numbers. The grouping changes. So I have 9 times 0 grouped. I'm going to go ahead and group 0 times 1. And the next one, I have 6 and 5 grouped. After I write down my numbers in their order, I can change the grouping. And the final one has a few more numbers, 1 times 2 times 3 times 4 times 5. I have my 1 and 2 grouped, but I think I'm going to group on this one, my 3 and my 4. I could have easily have grouped my 2 and 3, or my 4 and 5. Okay, any of those would have worked. In associative property, the grouping of your numbers changes, but the order of your numbers does not change. Okay, our final property that we're going to talk about today is distributive property of multiplication. And basically what this is saying is a number gets distributed throughout the problem. Way to remember, if you see a problem that has addition and multiplication, and it's asking you, is this commutative, associative, or distributive? It's going to be distributive. Now, there's other problems that have addition and multiplication that aren't distributive. But if you have a test question that says, which property of multiplication is this example, and it has addition and multiplication, it will be distributive property. But let's look at some examples of those. Okay, so an example of distributive property would be 4 times 3 plus 2. My 4 gets distributed throughout the problem. Remember how I told you way at the beginning of the year, it's like number 4 is going to a number party, and he has to shake hands with number 3 and number 2. Same with 9 times 7 times 1. Number 9 is going to the party. He has to shake hands with number 7, and he also has to shake hands with number 1. We have multiplication in the middle of our parentheses, and we have addition in the center, adding those two together. I've also told you that this is super helpful when you've got large numbers and you're not sure how to multiply. So if you have like 34 times, let's say 18, and that feels awkward. What you can do is say 34 times 10 plus 34 times 8. That's a lot more manageable. It's even something you could almost do in your head. 34 times 10 would be 340. 34 times 8, we could go 34 times 8, 32, 24, 25, 26, 27, 272, and we could multiply, we could add those together to find our answer. That's the main reason for distributive property. So let's let you do some of those. Okay, so let's think about number 1 going to the number party. What's he going to have to do? Well, he's going to have to shake hands with number 3, and he's going to have to shake hands with number 4. Number 2, going to the number party. He's going to have to shake hands with number 7 and shake hands with number 4. Now here's an example of distributive property where it's already happened. So if we think about reverting it back to an example that looks like that, it would look like 4, because it's what's been distributed throughout both of the problems, times 3 plus 9. I would get the same answer on both sides of the equation sign. 3 plus 4 is 7. 1 times 7 equals 7. 1 times 3 is 3, plus 1 times 4, that equals 7. 7 plus 4 is 11. 2 times 11 is 22. 2 times 7 is 14, plus 8 equals 22. Okay, so we're going to talk a little bit more about this today, and then we're going to be ready to answer some questions.